Type 1 diabetes is an autoimmune disease, and in the context of autoimmune diseases, it means the immune system's made a mistake and starts treating the body as if it was foreign and starts attacking the body. So in type 1 diabetes, what we see is a destruction of the pancreatic beta cells, and what that means is that the body can no longer produce insulin, and we see a lot of problems with blood glucose, and patients require multiple daily injections of insulin. So as people who study the immunology of type 1 diabetes, we're really keen to identify what are the critical factors of the immune response that are required to develop type 1 diabetes, because we think these are the best targets for new therapies for trying to treat and prevent type 1 diabetes. T cells are a critical part of the immune response against the beta cell, and much basic immunology research over the last, say, 20 years has identified that there are different types of T cells, different flavours if you will, and they have different jobs and use different molecules. So we've been studying a particular type of T cells called type 17 cells, and we believe we've found some molecules that they use that could be very important for the development of type 1 diabetes. T cells need to communicate with other immune cells and also the pancreatic beta cells when they respond to various antigens. And to do that, they secrete things called cytokines, which are messenger molecules. So these are things that are released from T cells and then function directly on the beta cells. So we think we've identified a new candidate in IL-17F that we think is very important for being a messenger molecule from T cells to lead to beta cell death. The experiments that we'll be doing in this funded grant is to use antibodies which will block the function of IL-17F in preclinical models, and we'll use those molecules to determine whether IL-17F is really important in the development of type 1 diabetes.